Good afternoon, everyone. So in this lecture, we'll solve some problems, some two problems, right? So one problem I'll be explaining you how to do, and the other one you have to do it by yourself, right? So we'll see what is the first problem. So just read the question. So here you have to find the incremental field strength at P2 due to the current element of 2 pi Az microampere meter at P1. The coordinates of P1 and P2 are 400 and 030 respectively, right? So what we have to find? We have to find what is the incremental field strength. So that is, we have to find what is DH, right? So it is clear that we have to use Biot-Savarts law here. At which point? At point P2. So at point P2 we have to calculate what is DH, and where is the current element placed? Current element, that is IDL, is placed at point P1. Point P1. So you have to note here the unit for the current element is microampere meter. The current element is given by I. It is given by IDL. Correct. IDL vector. So for I it is amperes and for DL it is meters. So it is microampere meter. That is the unit for current element. Right. So now we'll see the diagram for this question. Yes. Now when you plot 2 points, in the graph, in the form of the graph, this is point P1 400 and this is point P2 where it is 030, and this is where the current element is placed, I1 DL1. So this suffix represents it is the first point, right? And here point P2 we have to calculate what is DH. So I'll write this as DH2. That means I have to find what is the incremental field strength at point 2. That is why I'll name it as DH2. So now obviously the arrow will be towards this side because we are calculating the effect at point 2 due to point 1. So the coordinates of that is 400 and the coordinates of the point where we have to find the electric field intensity is 030. So final minus initial will be, what will be final minus initial? It will be 0 minus 4, 3 minus 0 and 0 minus 0, right? So that is what is written here for R12, and for this is the unit vector, right? So this is the formula what we are going to use. This you know that we got it from Biot-Savarts law, correct? So we need what is IDL1, which is already given in the question, right? And we need what is AR12. We need what is AR12. AR12. So we need to find what is AR12. That is the unit vector for this one. So now it will be yeah. Now AR12 by the definition itself, you know that it is vector divided by the magnitude. So R12 I told you how to calculate final minus initial. So you'll get minus 4AX, 3AY and 0AZ anyway. So divided by R12, the magnitude will be 5, that is root 16 plus 9. Correct. So this is what you get for AR12. Now what is the cross product we have to find? We have to find the cross product of I1 DL1 cross AR12, right? So I1 DL1 is given by 2 pi AZ, 2 pi AZ into 10 to the power 6. Anyway, we can take it later, that 10 to the power minus 6, right? And we have AR12. AR12 is AR12 is this one, that is minus 4 by 5 AX, minus 4 by 5 AX plus 3 by 5 AY, and AZ will be 0. So first we have to find what is ID L1 vector cross AR12 vector. So this is a cross product, you know how to find. It will be the determinant AX, AY, AZ 0, 0, 2 pi minus 4 by 5, 3 by 5, 0. So it will be minus 4 by 5 into 2 pi AY minus 3 by 5, 2 pi, 3 by 5 into 2 pi AX. So when you solve this, this is what you get, right? Now substituting it here, substituting this in this equation, we know what is R12. R12 is nothing but 5. So when you solve that, you'll get this answer, that is minus 12 AX minus 16 AY nano ampere per meter. Now revising it once more, how did we solve this? First we need to know what is the formula, right? So this is the formula from Biot-Savarts law. So this is what we have to find. DH2 we have to find, right? So we need to know what is IDL1 cross this unit vector AR12. So when you find the cross product of these two, right, you will get this equation, and then directly substituting in this formula, we get the answer like this. We get the answer like this, right? So going to the next problem. Next problem I'm not solving. You have to solve it by yourself, right? This is based on the current element. This is based on magnetic field intensity due to line charge, right? So here a current filament carries a current of 10 amperes in AZ direction on the Z axis. Find the magnetic field intensity H vector at point P 1, 2, 3 due to this filament if it extends from the first case, Z is equal to minus infinity to plus infinity, and the second case Z is equal to this is 0 to 5 meter, this is 0 to 5 meter, and the last one Z is equal to 5 to infinity, 5 to infinity. Now how to solve this problem? So first one, when you take this is from minus infinity to plus infinity, so you can directly use this formula which we derived in previous class. When after we solved Biot-Savarts law, we found what is H vector due to infinite line charge. So we got I divided by 2 pi rho into A phi cap. Now how to solve this problem? Now this is how the diagram will be for this. Now you will have like this x, y, z, correct. Now the charge is placed in this form. Now for the first case, the charge is placed like this from plus infinity to minus infinity, correct. So this will be x, y, and z. Now here you can see what is this rho. This rho is nothing but the perpendicular distance between the line and the point where we are calculating the magnetic field intensity. Now what I'll do, I think you have understood this diagram, right? Now where is the point we have to calculate the magnetic field intensity? Now, so this is some point where we have to calculate the magnetic field intensity, that is given as 1, 2, 3. 1, 2, 3. Right. We know that this rho is perpendicular distance from the line and the charge. Now what happens? What happens when you look this from the top? When you look this from the top, how does it look? You will have x like this and y like this. Correct. Y will be on this side. Now we are interested only with respect to x and y here because z is from plus infinity to minus infinity. Now if you see the infinite conductor will be like this. from plus infinity to minus infinity. Since we are interested only in the perpendicular distance, now we are interested only with respect to x and y here. Now x and y, how do you find? That will be x will be x y z is 1 to 3. So this will be 1 and this will be 2. So when you join these two lines, and find the resultant here, that will give you the perpendicular distance rho, right? So this is nothing but x and y. That is, in the problem it is 1 and 2, right? So what is rho here? Rho will be equal to root of 1 square plus 2 square. That will be root 5. So rho will remain same for all the problems, because in all the three cases the conductor is placed in z axis. So it will be root 5. Correct. It will be root 5. Rho will be equal to root 5. So we know what is the current I. We know what is rho. So we can find what is h vector. What is h vector? So h vector will be in the form of a phi. But here what they have told, you have to express the answer in Cartesian coordinate system. But whatever we have found here is in cylindrical coordinate system, right? So what you have to do, once you get this h vector has only one term, that is a phi. You have to use this formula. Sorry, you have to use the other one. You have to use the transpose of this one, where you have ax, ay and az. You have one more formula, you can check this, you can find the transpose of this, or else we have ax, ay and az is equal to, I think you will have here you will have cos phi, right? And here you will have sin phi, and here you will have minus sin phi, and here again you will have cos phi, and here you will have 0, 0, 1, again 0, 0. I hope this is correct. So this will be a rho, a phi and az, right? So now what we'll do, we know what is, instead of capital A here, you just replace it by capital H. You just replace it by capital H and rewrite the equation. So what we have to find, what we have here, we have only H phi. We have only H phi from the previous this one. That is, when you calculate that, you get something with respect to H phi. So now here only this will have some value, and this will be 0. This and this will be 0. So what will be AX? AX will be minus sin phi into H phi, whatever you get, right? And remember that don't write A phi here, because we are writing only the magnitude here, no unit vector. So we'll get what is AX, and what will be AY? AY will be cos phi into A phi, and AZ will be 0. AZ will be 0, right? So AX plus AY plus AZ will give you the answer in Cartesian coordinate system. I hope you understood. But before proceeding, I'm not sure with this equation. Just check this equation with the first module whether it is correct or not. It will be transpose of this one. So when you transpose this, so it will be cos minus sin 0. Yeah, I think it should be correct. Sin phi, cos phi 0, 0, 0, 1. I think it should be correct. Then you have cos phi sin phi, right? So what do you substitute for this phi? You have to calculate what is phi from this equation. You have to calculate what is phi from this equation. We know what is y, I think that is 2, and we know what is x, that is 1. So you will get what is phi. Just substitute the value of phi, then you will get h vector. You will get h vector in the form of something into ax cap plus something into ay cap, right? So this will be the answer for the first case. This will be the answer for the first case. Now what we got, first we got only with respect to a phi, we got the answer with respect to a phi, but after converting you will get with respect to Cartesian coordinate system ax and ay, right? Now how to solve the second problem? Second case, when z is from 0 to plus 5, 0 to 5, you have to modify the diagram, right? I'll write the conductor from here, z to this point, and this is 5. This will be 5, and this will be 0. And the point where we are calculating will be 1, 2, 3, right? It will be 1, 2, and 3. So you have to find what is alpha 2, what is alpha, I mean, no need of this alpha here. We need to find what is alpha 1, we need to find what is alpha 2, substitute in this formula, and you will get what is h in terms of a phi. Again you have to convert this into Cartesian coordinate system by using the same procedure what I explained here, right? Same thing for this one also. For the third case, it is from 5 to infinity, so the line will be from 5 to plus infinity, like this third case. Then again you have to find what is alpha 2 and alpha 1, substitute it, and then try to get the answer. So whatever answer you get, you please try to WhatsApp me. I'll just find whether it is correct or not, and then I'll let you know, or else I'll also try to solve this problem and upload in Google Classroom along with the slides, right? This is the task given to you for today. Please try to make use of the time and try to solve this problem, right? I hope everyone have understood. Only thing is, whatever answer you get will be with respect to a phi. Since they have asked you to convert that into Cartesian coordinate system, we have to use this equation and this phi equation, right? This equation we have to use to solve that one, right? So try to solve it by yourself. So we'll solve some more problems in the upcoming lectures on Ampere circuit law, right? Thank you.